All right, hello and welcome everybody. Welcome to the stream, and we are HackerFrogs. All right, today we're going to be doing two different topics today. And to kick things off, let's do a little redeem, and let's go hack the planet.
Hack the planet! Hack the planet! Shut up again!
All right, so what we're going to be doing today is we're going to be working on some SQL injection. So we've been building up to this. We've been...
Hack the planet! Hack the planet! Shut up again!
It was so nice we had to do it twice. So today what we're going to be doing is we're going to be doing some SQL injection today. We've been building up to this. We've been learning about SQL, the actual intended use of it, and today we're going to be exploring some SQL injection using the TryHackMe education platform. And after that, what we're going to be doing is we're going to be doing some OSINT on the world's most famous hacker. And the world's most famous hacker in this case is Mr. Kevin Mitnick. So this person right over here, this person is the world's most famous hacker. Kevin Mitnick was a bit of a legend back in the 1980s and the 1990s when he was doing all of his crimes, but he is now, well, he has since passed away. But before he passed away, he became a good guy, cybersecurity person, and we'll be exploring his life and all the shenanigans that he got up to during his life in the second part of today's stream. But in the first part, we're going to be talking about SQL injection, otherwise known as SQL injection. So let's start there. So today, this is the 5th Intro to Web Exploitation workshop. And in the previous workshop, we learned about the following web exploitation concepts. So we learned about SQL, the structured query language. It's a programming language used for managing data held in relational databases. Simply put, SQL allows users to access and manage data contained in relational databases, which are common components in most web applications. It is for this reason that SQL injection and SQL in general is something we want to pay attention to. In the previous workshop, we use SQL queries to retrieve relevant data to gather clues and solve the SQL murder mystery game. So if you remember last week, that's what we did, and we used a lot of SQL queries to do so. And today we're going to be moving on to the TryHackMe platform. So in this workshop, we're going to be learning SQL injection exploits through the TryHackMe platform. TryHackMe is a popular cybersecurity education platform with educational modules called rooms that span a great number of cybersecurity disciplines. So TryHackMe is a great resource for learning cybersecurity across a wide variety of subjects. And in this workshop, we'll be making use of one of TryHackMe's interactive rooms to learn more about SQL exploitation. But if we want to use the TryHackMe platform, we must first have a valid user account for the website. If needed, sign up for an account at the following URL. It's going to be https://tryhackme.com/signup. So what is SQL injection? So SQL injection is a web app vulnerability where SQL commands are passed to the web app database through insecure user input. So it's because the website is designed to insecurely handle user input that makes this vulnerability manifest. So SQL injection vulnerabilities can lead to sensitive data exposure, admin account takeover, web server takeover, and more. So we're going to be going over to the TryHackMe room to learn more about SQL injection. We'll be working through the TryHackMe room in a web browser. We're going to log into the TryHackMe website, then navigate to the following URL. So it's this link right here. I will provide it to everybody in chat who needs it. So I've pasted it into chat just in case you wanted to follow along. So let's go through the SQL injection room briefly. So over here, under task 1, it says, let me make this a little bit bigger for everybody to see. I want everybody to be able to see the text that's on the screen. It says here that SQL, structured query language injection, mostly referred to as SQLI, is an attack on on a web app database server that causes malicious queries to be executed. When a web app communicates with the database using input from a user that hasn't been properly validated, there runs the potential of an attacker being able to steal, delete, or alter private and customer data, and also attack the web application authentication methods to private or customer areas. This is why SQLI is one of the oldest web application vulnerabilities, and it can also be the most damaging. So in this room, we're going to learn what databases are, what SQL is with some basic SQL commands, how to detect SQL vulnerabilities, how to exploit SQLI vulnerabilities, and as a developer, how to protect yourself from SQL injection. So we need to answer the following question: what does SQL stand for? So the answer is at the beginning of the task. It is structured query language. So we just need to copy this, and we need to provide it to the task and click on submit, and then that task is done. So the next question we're going to ask is, what is a database? So the database is an electronically storing collections of data in an organized manner. The database is controlled by software called a DBMS, which is an acronym for Database Management System. So these DBMSs, they fall into two camps, either relational and non-relational. So the focus of the room is going to be on relational databases. So SQL is a relational database language, and the alternative to relational databases are non-relational databases, which are also known as NoSQL, NoSQL databases. So within a DBMS, you can have multiple databases, each with its own set of related data. For example, you might have a database called Shop, and within this database, you want to store information about your products available to purchase, users who have signed up to your online shop, and information about the orders that you've received. You'd store this information separately in the databases using something called tables. So you see here that the database is structured in this way. The top level is the database itself, and then within the database there are several tables. So this is the database server, and in the database server there might be multiple different databases. In this case, there are three databases, one called Shop, one called Staff, and one called Accounts. So these are the different databases, and within these databases they have different tables. So the Shop database has users, products, and orders. The Staff database has users, information, and audit. And the Information database has customers, orders, and payroll. So we took a look at databases and tables. What are tables? So a table is made up of columns and rows, and it's a useful way to imagine the table with a grid, with columns going across from left to right, containing the name of the cell, and the rows going from top to bottom, with each one having actual data. So in this case, we've got our columns over here. In this table right here, we've got three columns. There's the ID column, the username column, and the password column. And we also have a number of rows which contain the information that was relevant to the data in that row. So there's an ID, we've got the number 1, we've got a username, John, and a password associated with the username, which is this right here. We've got 3 of these rows, and they all have information that corresponds to their different columns. So each column, better referred to as a field, has a unique name per table. So columns can't share the same name within a single table. So for example, you can't have 2 ID columns in the same table, and you can't have 2 username columns in the same table. So If you want to go more in depth with this room, you can go ahead and read all the information in each one of these tasks. Unfortunately, for the sake of brevity, I'm going to be skipping past some of the information that we don't necessarily need to solve the room. So we're going to answer the questions below. The first question is, what is the acronym for the software that controls a database? So we've got a 4-letter acronym. If we remember, the database is controlled by something called a DBMS, and that stands for Database Management System. So we're going to copy that and provide that as the answer to the first question. And the next question is, what is the name of the grid-like structure which holds the data? So if you remember, we've got our columns and rows, and those columns and rows make up something called a table. So we can provide table as the answer here. All right, so we've got task number 3. What is SQL? So SQL, as we explored last time, is structured query language and is a feature-rich language used for querying databases. These SQL queries are better referred to as statements. So we can call each one of these queries, we can also call statements. Sometimes you'll usually hear them used interchangeably, these two terms. And the first thing we need to know is the select keyword, and it's the first query type that we're going to learn over here. So in this case, we're going to select star from users. So select star from users means from the users table, we're going to select star, and star in this case is shorthand for all of the columns. So whenever you select star from a table, you're selecting every column which exists in the table. So we can see that the next query is similar to the above, but this time, instead of using the star to return all columns in the database table, we're just requesting the username and password field. So we can select certain columns, in this case, username and password, from a particular table. So the table is users, and we're retrieving the username and password columns. And we only receive the 2 columns in this case. And the next thing we're going to learn is about limit. So the limit filter is what we use to limit the number of rows that are returned by a single query. So in this case, we can use limit plus a number to restrict the number of rows that are returned by our query to the number that is specified in the query. So limit 1 restricts it to only 1 row that is returned. And it's usually the first row that matches. Okay. And next we see another more restrictive query, which is select star, which is all columns, from the users table, where the username is equal to admin. So this is only going to return a specific row, and that row has to have the username column equal to the data under the username column equal to admin over here. So this is only going to return 1 column over here, since there's only 1 username, which is named admin. Okay, the next one we use is select star, all columns, from users, so the users table, where the username is not. So in this case, this symbol right here, the exclamation point with the equal sign, it means is not admin. So in this case, it's not going to return it where the username is admin, but it's going to return everything else. So we've got John, and we've got Martin, and we see ID number 2 is missing here because ID 2 would have been admin. Okay, so the next query we're looking at is select star from users where username equals admin or username equals John. So in this case, we're able to use the OR clause over here to hit on more than one specified filter over here. So username has to be admin, or username has to be John in order for the row to return. So this way we're able to get multiple rows from the query if the criteria fits. Okay. So the next thing we're going to cover is the and filter over here. So select star from users, so all the columns from users, where the username is equal to admin. So the username is equal to admin, and the password is equal to password, spelled like this. So what this is a typical login type of SQL query. So these type of SQL queries that log users in usually specify this kind of syntax over here. So it's going to be retrieving the rows where the username has to be correct and the password has to be correct. Okay, and the next thing we're going to look at is this next query right here, which returns multiple rows if they fit this certain criteria. So we're going to use the like clause to allow you to specify data that isn't an exact match, but instead either starts, contains, or ends with certain characters by choosing where to place the wildcard character represented by the percentage sign, this one right here. So we've got this query right here, select star from users, where username like A. So in this case, it's the username has to start with the letter A, but whatever follows after the letter A could be anything because the wildcard character is specified right over here. Okay, and in this case, they're looking for users where the username is like N. So in this case, the username has to end with the letter N. So in this case, you get things like John, which ends with an N, admin, which ends with an N, and Martin, which also ends with an N. Okay, and the next one over here is going to look for users where the username is like wildcard MI, wildcard, which means that it looks for the letters MI in the middle, somewhere in the middle of the string. So in this case, admin qualifies because the MI is in the middle of the string. Okay, so this next part is going to be very important because this next part allows us to do a certain type of SQL injection. And this is the union statement. The union statement combines the results of two or more select statements to retrieve data from either single or multiple tables. The rules to this query are that the union statement must retrieve the same number of columns in each select statement, and the columns have to be of a similar data type, and the column order has to be the same. This might not sound so clear, so let's use the following analogy. Say a company wants to create a list of all addresses for all customers and suppliers to post a new catalog. We have one table called customers with the following contents. So let's suppose that we have this table right here with all of our customers, and we've got the name of the customer, the address, their city, and their postal code. And we've got another table called suppliers with the following contents. So this is essentially the same, except that instead of the name of a customer, we're looking at the company name with our suppliers in it. So we have to use the following SQL statement. We can gather results from the two tables and put them in one result set. So we're going to select these four columns rather, from the customers table, and we're going to also union select these four columns from suppliers. So the result is that in this first column, we've got our name and company name as the first column, and then the following three columns are the same between the two tables. But we've managed to put information from two different tables into the same search result. All right, so next we're going to take a look at the insert statement, which tells the database we want to insert a new row of data into the table. So as far as SQL injection is concerned, we're not really going to cover this particular keyword, but this is the keyword that is used to insert new rows into a table after it's already been created. Okay, and likewise, this update statement is going to replace information that is already there with some new information that we supply in this case. And we also have the delete statement, which tells the database we want to delete one or more rows of data. So in most cases, when we're doing security testing, we're not going to be deleting any user's data, and we're probably not going to be engaging in destructive acts. But just for the sake of completeness, we should know that inside of SQL, we're able to delete rows from the tables. Okay, so let's answer the following questions. So which SQL statement is used to retrieve data? So that is the select statement. So let's see if lowercase works. It works, awesome. Which SQL clause can be used to retrieve data from multiple tables? So the SQL clause we use to retrieve data from multiple tables, this one's important for a little bit later, and it is the union clause. And the last question is, what SQL statement is used to add data? So in order to add data, we have to use the insert keyword. Okay, so let's take a look at what is SQL injection. So the point wherein a web application using SQL can turn into SQL injection is where user-provided data gets included into an SQL query. So what does this look like? So take the following scenario where you've come across an online blog, and each blog entry has a unique ID number. The blog entries might be either set to public or private, depending on whether they're ready for public release, and the URL for each blog entry might look something like this. So we've got website.thm, and then we've got blog, and then a URL parameter with an ID number. So the URL parameter lets the web page know which file to load up in this case. You can see that the blog entry selects come from the ID parameter in the query string. The web application needs to retrieve the article from the database and may use an SQL statement that looks something like the following. So this is the SQL statement that's going to retrieve the blog file. So it's going to be select everything from blog where the ID equals 1 and private equals 0, limit 1. So limit 1 means it's going to retrieve a single entry, and we have to make sure that private, in this case, is the blog entry set to private, and it has to be false. And here, this is where we're able to specify which blog entry we want to retrieve. Let's pretend that the article ID 2 is still locked as private, so it cannot be viewed on the website. We can now instead call this URL. So it's going to be ID equals 2, and then we block off the rest of the statement right here. So in this case, we're injecting SQL code into our query, and we're able to get the system to do something that it's not supposed to do. So this in turn produces this SQL statement right here. So everything up until here is executed. So select the blog article where the ID is equal to this number, except that because we supplied this code right here, this part of the code is not run. So the part where we have to specify that it has to not be private is set to false. So in this case, we would be able to retrieve blog entries that are not yet set to public. Okay, so the next question is, what character signals the end of an SQL query? So every SQL query has to end with the following character right here, which is a semicolon. This is typical for a lot of programming languages. So just click on that to submit, and we're done. Okay, so now we're going to be moving on into the actual SQL injection portion of this room. We need to go to our inbound SQLi task, and we need to click on the Start Machine button over here. So it seems like you're on a small screen or mobile device. For the best experience, switch to your desktop or with a minimum of 9 inches. I'm going to start the machine anyway. Okay, so after we load up this this website, we should be able to put this this virtual machine in its own web browser tab, and that's going to alleviate some of the problems that we have with the cramped space over here. But that's going to take about a minute and a half, so we're just going to hang tight. And we're going to read a little bit about the in-band SQL injection. So in-band is a type of SQL injection. It's generally categorized into 2 different types. Let's see if I have some. I have some slides to show over here. So in a web app, if the statement were to be supplied by the user, it would log in the user if the statement returned true. So select everything from users, where the username is this, and the password has to be this. So this is typical. The username and the password have to match in order for the user to be logged in. So in the next task, we're going to be performing in-band SQL injection, and that's SQL injection where the results of the injected query can be seen in the output of the web app. This is considered to be the easiest type of SQL injection to exploit. So let's take a look at the progress of our virtual machine loading up. Not quite yet. So there are 2 types of SQL injection. There's in-band. Okay, so there's in-band SQL injection. There's error-based SQL injection, which is a type of in-band SQL injection. There is union-based SQL injection, which can be either in-band SQL injection or what is also called blind SQL injection. So I'll explain the different types of SQL injection in just a little bit. Okay, so inside of our virtual machine here, we can put this one in its own browser tab, and we can do that by using the following option right here, which is labeled View in Full Screen. So just click on that, and that's going to put the this web page in its own browser tab. So back at the TryHackMe page, we can close this one out. We can click on this button right here, labeled Exit Split View. And then we will have plenty of room on our TryHackMe web page, and we will also have our SQL injectable website right here. So before we do our exploitation, let's read a little bit more about what this injection entails. So in-band, which is the type of SQL injection we're going to be performing, refers to the same method of communication being used to exploit the vulnerability and also receive the results. So when we're talking about a web app, that means that the web app is also going to show the same results as the web app is going to show the results of the SQL injection. So that's why we call it in-band, because it shares the same interface. So we've also got our error-based SQL injection, and this is a type of SQL injection that is most useful for easily obtaining information about the database structure, because error messages from the database are printed directly to the browser screen. This can often be used to enumerate a whole database. So let me show you how. So over here, we've got our URL right here, and this is the point at which we can inject our malicious SQL commands. So right over here, we've got an SQL query, select star from the article table where the ID is equal to 1. But if we're to inject some sort of SQL commands or some sort of SQL syntax, such as a single quote right here, so we're just adding a single quote over here at the beginning, and if we were to send this, then we're going to get an error message. And because we can see the error message, and it tells us about SQL stuff, we know that this particular endpoint is probably SQL injectable. So we see that we have an error message that talks about SQL syntax, and that's because we sent some SQL syntax along with the URL right here. So we typed an apostrophe after the ID equals un, and we pressed enter, and we saw that this returned a SQL error telling us about an error in the syntax. So the first thing we need to do to do SQL injection is to return data to the browser without displaying an error message. First, we're going to try using the union operator so we can receive an extra result if we choose it. So try setting the mock browser's ID parameter to 1, union select 1. So we're going to do that inside of the URL over here. So it's going to be 1 union select 1. So 1 in this case is referring to a column. And in order to do union select, we have to make sure that the number of columns that are retrieved by both of these queries are the same number of columns. So it says here select all columns. We don't know how many columns this is. So we can try sending this particular payload right here. And it's going to say the select statements have a different number of columns. So in order to figure out how many columns we need to send, we just need to iteratively try a number of columns. So we first sent 1 column, then we're going to try 2, and then we're going to try 3. So we're going to do 1, 2 for our next payload to see if there are 2 columns. And we see that we see the same error message. So we're going to try 2. We're going to add 3 to that. Okay. And after we send a union select with 3 columns, then we get a non-error message. So what does this mean? So after we sent this payload right here, the error message is gone and the article is being displayed. But now we want to display our data instead of the article. The article is displayed because it takes the first returned result somewhere in the website's code and shows that. So inside of our SQL injected payload, we see the numbers over here. We've got our number 1. Actually, no, this is number 1 right here. So we are not able to see what we sent as the union select. So the union select is 1, 2, 3, but we're not able to see any of this in the output over here. So we're going to try to figure out how to include this in our output. So the article is displayed because it takes the first returned result somewhere in the website's code and shows that. And to get around that, we're going to need the first query to produce no results. And this can simply be done by changing the article from 1 to 0. So if we change the ID number to 0, that means that there's no relevant article that corresponds with that. And instead, we're going to see the numbers 1, 2, and 3, which is what we sent in the payload. So let's go over. Let's go over here and let's select the ID number 0 over here. So when we send this, we're going to see that our number 1 appears over here, our number 2, so these correspond with the numbers that they're sending over here. So the number 2 goes over here, and the number 3 goes over here. Now what we're going to do is we're going to start using these return values to retrieve more useful information. First, we're going to get the database name that we have access to. So we're going to replace the third column with this function right here. And this function right here is called database. And on a lot of SQL systems, the database function is going to return the name of the database that's being used by the system. So let's do this. Okay, so instead of a third column, we're going to replace this with the word database with a couple of parentheses, which indicates that this is a function. So we're going to send this off, and the place where there was the number 3, there's instead the name of the database, which is SQL _1. Okay, so now that we have the name of the database, we can do more enumeration on the database. Here we see our next query will gather a list of tables that are in the database, and it's going to be the same payload except that in the place of 3, we're going to be using this command right here. Group concat table name from information underscore schema.tables, where table schema equals SQLi underscore 1. So this is a method of retrieving table names from certain SQL databases. So we're going to copy this, and we're going to be using this as our payload. We just need to paste in the instructions. So this is the SQL query being sent in this case. Okay, so we're going to send it off. So in this case, we've got 2 tables. There's the article table and the staff users table. So we've got 2 tables here. So there's a couple of new things in this query. First of all, we've got the group concat method over here, which is going to get the specified column, in this case the table name, from multiple returned rows and put it into one string separated by commas. So over here, because we're using the group concat method over here, we see that something that was supposed to be printed on multiple lines is going to be printed on a single line and separated by these commas. Okay? So the next thing is the information underscore schema database, and every user of the database has access to this, and it contains information about all the databases and tables the user has access to. In this particular query, we're interested in listing all the tables in the SQLi underscore 1 database, which is the article and staff users table. So as the first level aims to discover Martin's password, the staff users table is what interests us. So we can utilize the information underscore schema database again to find the structure of this table using the below query. So this query over here is going to get the names of all the columns from the information schema.columns table, where the table name is equal to staff users. So we're able to specify, in this case, what information we're getting, and because we want to get the names of all the staff users, this is the query we use. So I'm just going to copy this. And then paste it into here and send it. Okay, so we have the following columns in that table. We've got the ID, password, and username tables. So now that we have the three columns for the staff users table, the ID, password, and username, we're going to use the username and password columns for finding our query to retrieve the user's information. So what we're going to do is we're going to retrieve all of the usernames and passwords in that table. And we're also going to include a separator, which is going to be a line break. And we're going to get it from the staff users table. So let's just grab this payload. And supply this to the SQL injection. Okay, so we see here that we've got three usernames. We've got the admin user, the Martin user, and the Jim user. And because the goal of this particular exercise was to get the user Martin's password, and this is it, we can copy this and supply it to the answer field, and then click on check password. Okay, that was the correct password, and we get a flag for our efforts. So let's copy this flag, and then let's finish off the task. So again, we used the group concat method to return all the rows in one string and make it easier to read, but we also added the colon, the comma. What is this? The colon. So the colon to split up the username and password from each other. Instead of being separated by a comma, we've chosen the HTML BR tag, which forces each result to be on a separate line to make it easier to read. So we read the password and we submitted it. So we can now submit the flag over here. So paste in the flag that we got after we submitted the password, and the task is done. Okay, so we're only going to be covering one more task in today's workshop, and we're going to be covering the rest of the tasks from task 7 until task 10 in next week's workshop. But this is a more interesting part of SQL injection because it deals with logging into web apps without knowing the username and password. So this is the blind SQLi authentication bypass. So we're talking about the other type of SQL injection now. Before we were talking about in-band SQL injection. Now we're talking about blind SQL injection. So unlike in-band SQL injection, where we can see the results of our attack directly on the screen, blind SQL injection is where we get little to no feedback to confirm whether or not our injected queries were, in fact, successful or not. And this is because the error messages have been disabled, but the injection still works regardless. It might surprise you that all we need is that little bit of feedback to successfully enumerate a whole database. So now we're going to be talking about the infamous authentication bypass. One of the most straightforward blind SQL injection techniques is when bypassing authentication methods such as login forms. In this instance, we aren't that interested in retrieving data from the database. We just need to get past the login. Login forms that are connected to a database of users are often developed in such a way that the web application isn't interested in the content of the username and password, but more in whether the two make a matching pair in the users table. In basic terms, the web application is asking the database, do you have a user with the username Bob and the password Bob123? And the database is going to reply with either a yes or no, true, false. And depending on that answer, dictates whether the web application lets you proceed or not. So taking the above information into account, it's unnecessary to enumerate a valid username password pair. We just need to create a database entry, a database query that replies with a yes or true. Breaksec is raiding with the party of 5. Welcome, welcome, raiders. And Breaksec, what were you covering in your stream? I'm curious to know. So everybody, what we're doing is we're just doing a little bit. We're coming towards the end of our SQL injection room over here. Well, not the room, but this is the end of the first part that we're covering over here. So we're going to be doing the infamous authentication bypass for SQL injection. So we're going to do our practical portion. Level 2 of the SQL injection example shows this exact example. We can put it in the box labeled SQL query, that the SQL query to the database is the following. So it is because the typical query that logs in a user is something like this. Select star from users from username, and the username is whatever is in here, and the password is whatever is in here, and it's going to be limited to 1. Excuse me, I need to take a little drink. And we see some first-time messages over here. So it is Cyber Centurion. Hello, Cyber Centurion. All right, so Breaksec just rated us. Let's send a little video redeem, and this one's going to be all the things. So this is the famous nerdcore rap song about hacking all the things. Welcome, welcome, Cyber Centurion, and thank you very much for following.
This one's dedicated to all the hackers. Yo.
Sorry about that. Okay, so everybody, let's proceed. Okay, so what we're demonstrating is the SQL injection login bypass technique. So over here, just in case anybody wanted to follow along, we're covering this room in TryHackMe right now. So in the chat, I've included the link, and this is the SQL injection LM room. So we've got our SQL injectable website rather, and we've got our login form. So let me explain how the SQL injection bypass works. I've got some slides. Okay, so let's see. Right, so this is SQLi authentication bypass. It's a SQL injection where the error messages. So we're talking first about blind SQL injection. And this is SQL injection where the error messages resulting from improper SQL queries has been disabled, but the requests are going through nonetheless. So authentication bypass is a type of blind SQL injection where insecurely written code allows the login of a user to a web application without the proper use of the username and password. So this is the string that we're talking about. The most basic authentication bypass SQL command is illustrated by the SQL command shown above. Note that there is a space present in the command after the double dashes. So after these double dashes over here, there should be a space. Sometimes the space matters, and sometimes the space doesn't matter. It really depends on the web app in question. So what this bypass does, or what's in the bypass, this payload, what it does, is the single quote over here is going to close out the original query. So we've got username, and we're going to close out this query, and it's basically going to be an empty string. If this portion is not included, the SQL database will return an error. So we need to include this right here. The next part, or, is this is what enables the bypass, because it enables us to create our own true statement. So in most cases, the SQL statement just has to return true in order to log us in. And in this case, we use the OR filter, an OR clause in order to create a true statement, which is the next thing. Even if there's no matching username, because the OR conditional is used, the overall query can return true if we supply the correct statement, which in this case is 1 equals 1. So in terms of programming logic, 1 equals 1 is equal to true. Then the double dashes. I need more caffeine asks, would an AND also work? So the AND would not work in this case, because in order to make the AND statement true, we would have to supply a valid username. And because we don't necessarily know a valid username, if we did know a valid username, then the AND statement would also work. So then we supply the double dashes in the space, which is going to comment out the rest of the original query. Thank you very much for following. I need more caffeine. And I need more caffeine. Let's give you a little video redeem as well. So we're going to redeem go to hack.
Mr. Hat, may I please be excused from class?
Well, Kyle,
Yes.
you hear me? You go to
Hack.
You go to
Hack.
and you
Have a great day.
All right, I need more caffeine. Have a great day. Okay, so where were we? So okay, so we've got the double dashes in the space, which is going to comment out the rest of the original query. So like I said before, we can use an AND instead of an OR if we know a valid username. So let's take a look at the vulnerable web app over here. So we see over here, we've got our SQL query which logs us in. So it's select star from users rather, where the username is equal to empty string and the password is equal to empty string limit 1. So this is what it's checking. But we can inject our SQL authentication bypass payload right here. And for the password, it doesn't matter what we supply because we've commented out the rest of the SQL string by using these characters right here. So this portion of the query is not going to run. So what we're doing is we're selecting from the users where the username is blank. Oh, I forgot to put the OR in here. So we're selecting from usernames where the username is blank or 1 equals 1, which is the true statement. And then we comment out everything else in the query. So that means that when we send this, the SQL statement is going to equate true, and then it's going to log us in as the first user in the usernames table, which is usually the admin user. So we're going to send this, and that's going to log us in. So because we're logged in, we get a flag over here. So THM SQL injection, great. We're going to copy this. So this is this works for quite a number of CTF exercises. There are CTF exercises where they've got faulty login pages, and you're able to log in with the SQL bypass technique. So if you want to learn a little bit more about the SQL bypass technique, there's hack tricks. So the hack tricks website has a whole section on this. SQL bypass, login bypass. So if you wanted to read a little bit more about this, you can go ahead and go over to this article over here, and it talks more about it. But for us, let's copy this flag and we'll just supply it to the TryHackMe task, and we'll finish this task. So the question is, what is the flag after completing level 2 and moving on to level 3? It's this right here. We click on submit, and our answer is incorrect. Let's go back. So I Need More Caffeine says, I'm not very familiar with manual SQLi, and your explanations are great. I usually just go for SQL map. So it's important to, I understand that SQL map is very popular, and is very popular because it makes the automation of very tedious tasks like blind SQL injection or Boolean-based SQL injection and time-based SQL injection. Those can be very tedious to do. So you'll usually want some sort of software to automate that. But learning how to do it manually, it means that you understand a little better about what's going on under the hood. So I would say that that doing at least up until task number 7 in this particular room is very good for understanding what exactly is going on when we do blind SQL injection. But we're going to be covering tasks 7, 8, 9, and 10 in our next class. But we're only doing up until 6, task 6 in this one. So let me just grab that. So first we need to click on level 3, and then we have a new flag over here. So this is the section where we have to learn about blind SQL injection, and this is blind Boolean-based SQL injection. Okay. Oh, my voice is shot. Hold on. Okay, I think I might be calling it a stream pretty soon because I've been talking all day. But thank you very much to everybody who joined me to talk about SQL injection. I was going to talk more about Kevin Mitnick, the infamous hacker, in the next portion of the stream, but I think I'm going to call it because my voice is going a bit. Well, thank you very much. I need more caffeine. So let me just submit my flag over here. So blind SQL injection. I'm going to submit my flag, and all right. So everybody, next week we're going to be covering the next 3 tasks over here, the next 4 tasks over here rather, and on Wednesday we're going to be doing some SQL injection practice. So we've got our streaming schedule over here, and on Wednesday we're going to be doing Web App Hacking Basics extra credit, and that's going to be SQL injection practice. And then we're going to be talking about some famous hacks, the Sony Pictures hack, and the Bangladesh bank heist. So please look forward to that. I'm sorry I wasn't able to get to this topic today about Kevin Mitnick because I definitely need to rest my voice a bit. I was teaching some youngsters today, and I was talking for a couple hours straight, and it kind of ruined my voice. But thank you very much to everybody for joining today. Let's find somebody to raid so that you guys can go and do some more infosec learning. We have cyber insecurity. Let's send the raiders over to this particular channel. Be sure to say hi and tell them that the Shy Hat sent you. All right, everybody, before we go, let's do one last Hack the Planet.